KCET 2025 aspirants, welcome back to our channel Diksha Karnataka. In today's video, we are going to solve KCET 2023 chemistry paper. So in this video, we'll be solving the first 30 questions, that is from question number 1 to question number 30, and in the next part, we'll be solving from question number 31 to question number 60. Okay, so what you have to do is you have to take a pen and paper and sit, you have to see the questions and try to solve them, and if you are not able to, you need to see the solutions here, right? So the PDF of this question paper will be available in our WhatsApp channel. So the link of the WhatsApp channel will be there in the description section. So please join them. Okay. So yes, now let's get started with this. So we'll be discussing questions from part 1, that is question number 1 to question number 30 of chemistry KCET 2023. Okay, now let us see the first question. In which of the following reactions rate constant has the unit of mole liter inverse second inverse? Now if you see, for any reaction, the unit of rate constant for any general reaction is equal to moles 1 minus n liter n minus 1 second inverse, right? So now they have asked you this one. Okay, so moles power is 1 here, so let us equate this one. So I'll tell 1 is equal to 1 minus n. So you can see here I have equated the power of moles in the given question and from the general equation 1 minus n and 1. So if I solve this, I'll get n is equal to 0, right? So the question here is asked that which of the following reactions is of 0th order reaction, right? So see how indirect the question is. It is not directly asking you like give which of the following is a 0 order reaction, rather it has given you in a little tricky way, right? So it has given you the unit of K. So from this unit of K, first we need to find the order, that is which order reaction, and now we can see that out of these options which is a 0th order reaction. Okay, so this question is from one of the very important topic, that is chemical kinetics, right? Okay, now if you see here, 0th order reaction, you know, decomposition of HI on the surface of gold, adsorption process occurs through 0th order reaction. So the correct answer for this question will be option number C. Okay. Okay, now what you have to do is you have to do questions with me, and at the end you need to post your scores also. Okay, so now let us go to second question here. So for a reaction, the value of rate constant. So again, this question is from the topic, that is chemical kinetics. Okay, the chapter name is chemical kinetics, and if we see Arrhenius equation and everything is there, so the subtopic here is Arrhenius equation, right? I will be writing the formulas and we'll be revising the concepts and then we'll be solving the questions. Okay, now let us see. For a reaction, the value of rate constant at 300 Kelvin is given to you 6 into 10 to the power of 5 second inverse. So let us write this data. So what is K value? K is 6.0 into 10 to the power of 5 second inverse. Okay, now the value of Arrhenius factor A at infinitely high temperature is, okay, now if you know Arrhenius equation, so let us first revise the Arrhenius equation. Arrhenius equation is equal to K equal to A into e to the power of minus EA, that is activation energy, by RT, where R is the gas constant, T is the temperature, A is the pre-exponential factor, and K is the rate constant. Now the question is asking what is the value of Arrhenius factor. So the question is asked for A when the temperature is very high, right? So if the temperature is infinitely high, that means what, I can put T as infinity. So what I have got here, another data point from the question, that is T is equal to infinity. Now let us substitute that here. So I'll get K equal to A into e to the power of minus EA by R into infinity, right? So this will become 0, anything 1 by infinity or anything to the power of infinity is 0, so e to the power of 0 will be 1. So what I'll get, K is equal to A. Now we know the value of K, the value of K is 6 into 10 to the power of 5, right? So that is the value of A. So the correct answer for this question will be option number C. Okay, so this is, again, let us try to assign each question easy, moderate and tough. Okay, so I think this question will come under moderate section. Okay, according to me. You also tell me in the comment section whether you find this question as easy or moderate or tough also. Okay, now coming to question number 3 here. The rate constants K1 and K2 for two different reactions are 10 to the power of 16. So okay, this question is again from chemical kinetics. and the subtopic here is you can see it is from that same Arrhenius equation. Okay, K1 and K2, the rate constants K1 and K2 for two different reactions are given to us. The temperature at which K1 is equal to K2. Okay, so now let us write down the values that is given to us. K1 value is 10 to the power of 16, okay, into e to the power of minus 2000 by t. Okay, and then you have K2. K2 is 10 to the power of 15 into e into minus 1000 by t. Okay, now the question here is the temperature at which K1 is equal to K2. Okay, so let us now find, we know this Arrhenius equation, already we have discussed. Now K1 is equal to K2 at what temperature? So let us equate these two. So I will get 10 to the power of 16 e to the power of minus 2000 by t is equal to 10 to the power of 15 into e to the power of minus 1000 by t, right? So now if I divide this one on this side, I'll get 10 into e to the power of minus 1000 by t is equal to e to the power of minus 2000 by t and e to the power of minus 1000 by t. Now let us take this one this side, so I'll get 10 into e to the power of minus 2000 by t by e to the power of minus 1000 by t is equal to 1. Now let us solve here again. So we'll get 10 to the power of minus 1000 by t is equal to 1. Okay, now what we can do, I'll take this 10 on one side, so I'll get e to the power of minus 1000 by t is equal to 1 by 10, that is I'll write 10 to the power of minus 1. Now if you take ln on both sides, I'll get 1000 by t is equal to minus 1. Now we'll convert this into log also. Okay, so if I convert it into log, I'll get into 2.303. So what will be the value of t here? The value of t, I'll subtract here, I'll erase this part. Okay, I hope you can see this solution here. Now let us calculate for t. Okay, so the t value will now be 1000 by 2.303 Kelvin, right? So the correct answer for this question will be option number B. Please check the simple equation, there is nothing more. We have just taken the two K1 and K2 and then we have equated it and then we have tried to find the value of t. Okay, so the correct answer for this question will be option number B. Okay, so you can see up to 3 questions we have solved now from kinetics only. Okay, now coming to question number 4. Okay, so during the electrolysis, so this question, now we have moved to the chapter that is electrochemistry, right? Okay, one another important topic, very high weightage topic for your KCET examination. Okay, now if you see during the electrolysis of brine by using the inert electrode, now brine is what? NaCl plus water, right? So what happens? We have the ions here Na plus and we have the ion Cl minus, we have H plus and we have OH minus, right? So these are your cations, positively charged ions, they will move towards the negatively charged electrode, that is cathode, right? And these are negatively charged ions and they'll move towards the positively charged electrode, that is anode. Now what happens? Cl minus will undergo oxidation and will produce Cl2 at anode. So the correct answer for this question is Cl2 is liberated at anode. Okay, very easy question. Next, okay, so we did not give rating for this question also. I find it is little moderate type question. Okay, not very direct question, but yes, this one is easy question. Okay, now coming to 5th question here. Consider the following. So Ag plus solution. So again this question is also from your electrochemistry. Okay. Now if you see here, consider the following 4 electrodes, the reduction potential in volts of the electrodes in the order. Okay, so let us see how to calculate the electrode potential, right? For a particular electrode, how to calculate the electrode potential. So I'll write the formula here. So E of the electrode is equal to E naught of the electrode minus 0.059 by N log of 1 by that ion. Okay, this is the formula, right? So now if you see, we need to put the concentration of Ag plus, right? So now if you see here the concentration for option number 1, like for A, for the A electrode, I'll get E equal to, I'll use the different pen here. Okay, so we'll get E is equal to E naught minus 0.059. Now N value is 1. What is the reaction here? Ag plus 1 electron is giving you Ag, right? Here the concentration of products divided by the concentration of reactants ion. Here there is no ion, so that is why 1, and here we have Ag plus, that is why it is concentration of Ag plus, right? Okay, now if you see here, I'll put 1 log of 1 by, here what is the concentration? 10 to the power of minus 4, right? So now if this goes up, I'll get E naught minus 0.059 by 1 log of 10 to the power of 4, and that becomes 4 log 10, right? So what I can do is, I'll write it as into 4, right? So from E naught, this value has to be subtracted for option number A. Now similarly, if you do for all other options, so what I'll get for option number B, I'll not solve it now, I'll just write down the values. You can see for B, I'll get E equal to E naught minus 0.059 into, how many here it is? 10 to the power of 1 will get, so into 1, right? You just try this in this way, okay? Next, we'll solve for C. For option C, if you see, we will get E equal to E naught minus 0.059 into, for option C it is 10 to the power of 2, so that will be into 2. Now for option number D, for option D, if you see, we'll get E is equal to E naught minus 0.059 into 10 to the power of 3, so it is multiplied by 3. Now you see, where the subtraction part, this part is smaller here, right? So you are subtracting a small number from E naught value here, and you are subtracting a big number from E naught here. So where the reduction potential will be highest? It will be in B, right? E naught, suppose let us assume that E naught is 10, for example, just a number. Now from E naught you are subtracting 1, you are subtracting 2, you are subtracting 3, and then you are subtracting 4. So where you are subtracting less, that value will be highest, right? So that is what I am saying here, because here a small number is subtracted, so this reduction potential will be maximum. You need not do any calculation here, just you have to understand that here we are subtracting a small number, so that is why E naught value will be highest in that case. So we'll get B will have the highest reduction potential. After that we are subtracting a smaller number here, so after that C, then we have 3, that is D, and then we are subtracting a very big number here compared to all these 4, so that is why then it will come E. So the correct answer for this question will be option number D. Okay, now going to, so this question again I will mark it as moderate. Okay, now coming to the next question. So we have already seen 2 questions from electrochemistry, 3 questions from kinetics. Okay, now coming to question number 6, again resistance, you know this question is also from electrochemistry. Okay, and what is the subtopic here? The question subtopic is something about like conductance. Okay, now let us see. The resistance of a 0.1 molar weak acid HA in a conductivity cell is this much. So let us write that the data is given to us. Resistance is 2 into 10 to the power of 3 ohm. Okay. Now the cell constant of the cell is, so cell constant is L by A, and that is your 0.78 centimeter inverse. Okay, and the lambda naught m of the acid, so we have been also been given with lambda naught m, that is the molar conductivity at infinite dilution, as 390 s centimeter square mole inverse, right? Now the pH of the solution is, so for pH of the solution we need what? To know the concentration of H plus. So what is the formula of pH? So we'll write, question is pH formula. pH formula is minus log of H plus, right? Now how to get H plus concentration? How to get H plus concentration for a weak acid? For a weak acid, the H, we can see this is a weak acid, right? So for a weak acid, the H plus concentration is C alpha. Okay. Now C alpha, what is this alpha? Alpha is degree of dissociation. Now how to calculate degree of dissociation based on the molar conductivities? We have the lambda is equal to lambda m by lambda naught m, right? Now how to, lambda naught m is given to us, right? Then how can we calculate lambda m? For lambda m the formula is kappa into 1000 by C, right? Now if you see, we don't know even kappa also. Then how to calculate kappa? Kappa is equal to 1 by R into L by A. Okay. Now you see, we have to go from the lowest step to highest step. This has to be our step number 1, step number 2, step number 3, step number 4, and here finally step number 5. So what I'll do, see here we have R by R data also, we have L by A data also. So let us substitute that. So and let us calculate the K value first. So K value will be 1 by R, that is 2 into 10 to the power of 3, okay, and L by A is 0.78, right? So now if I calculate here, I'll get 0.39. So 0, I can write it as 1 second, yeah, we can write it as 3.9 into 10 to the power of, here it is my, so 0.39 into 10 to the power of minus 3 it is there, right? So now I can write it as 3.9 into 10 to the power of minus 4, right? So I got the K value first. Now what we can do, step number 2 is to calculate molar conductivity. So let us calculate molar conductivity, that is kappa into 1000 by C. So kappa is 3.9 into 10 to the power of minus 4, then into 1000 10 to the power of C, 10 to the power of 3, then C, concentration is 10 to the power of minus 1, right? So now if I solve this one will become 10 to the power of 4 plus 4 minus 4 will get cancelled and I'll get 3.9. Lambda molar conductivity I got 3.9. The unit here is S, centimeter square mole inverse. Okay, so I have completed. Now let us see here, this was my step 1 and this is my step 2. We have done with these two. Now step 3 is to calculate alpha. So I am erasing the step 1 here. Okay, so little space is not there, so I am erasing this part and we'll calculate the alpha part here, right? Okay, so let us go to now step 3. Okay, so step 3 is calculation of alpha. So alpha is lambda naught m, lambda m by lambda naught m. Lambda m I already calculated 3.9, right? And this is 390, right? So I'll get 0.01. Okay, we'll get 0.01 is alpha value. So we have done with step 3 also. Now we'll calculate H plus concentration. Okay, so I'll erase here step 2. So what is H plus concentration? For a weak acid formula is C into alpha, right? So we have seen that we have C as 0.1 and alpha we got as 10 to the power of minus 2. So step number 4 here is to calculate the H plus concentration, that is C into alpha, where C is 10 to the power of minus 1 and alpha is 10 to the power of minus 2, right? So how much I'll get? This one as 10 to the power of minus 3. Now we have reached step 4 also, and now we are at the final step where we need to calculate the pH of the solution. So again I am erasing this one. So if you see, we have step number 5, pH is equal to minus log of H plus concentration 10 to the power of minus 3. So I'll get 3, right? So the correct answer for this question will be option number C, that is 3. Okay, so little lengthy question I'll tell. Okay, the number of steps are more, but it is not at all a difficult question. So this question again I'll put it under moderate section. Okay, I hope all the formulas are clear. So first you need to start what is asked. So for this we need H plus concentration. For H plus I need this one. For C, okay, it is given. For alpha I need this one. For lambda 1 we need this formula. For kappa we need this formula, right? So that is how you have to arrange all the formulas, and then you have to substitute one by one, go from the lower to the higher and find all values and do the calculation. I hope this question is clear. Now let us go to the 7th question. The reducing, again this question is from your electrochemistry. Okay, so the reducing agent among the following is, okay, this is very easy question. I think we need to just find out reducing agent means the compound itself should undergo oxidation, right? So let us see, Ag oxidation state is 0 here, and if you see here it is Ag is x minus 2 is equal to minus 1, so Ag is plus 1. So silver is undergoing oxidation, but in option silver is not there, so we can leave silver. Now if you see the next one we have here is next reaction, we have zinc here. If you see zinc here, and the oxidation state of zinc here is Zn is x, right? For Zn let it be x, then Cn minus 4, and then we have minus 2, so that means x is equal to plus 2, right? So Zn is undergoing from 0 to plus 2, right? So definitely zinc is undergoing oxidation, so the correct answer here is option number D. Now Cn here also minus 1, here also minus 1, no change in the oxidation state, and water, if you see this side also water is there, oxygen is there, no change in the oxidation state. So hydrogen is still here plus 1, oxygen is going from 0 to minus 2, it is undergoing reduction. Okay, so the correct answer for this question will be option number D. I hope this is clear. So this question I will mark it as easy question. Little complicated reactions are given to confuse you, but if your basic is strong, if your fundamentals are very clear, then this question is an easy question. Okay, now let us go to the next question. I hope you all are solving correctly with me. Next question, okay, for the formation of which compound? So this question has come from your metallurgy chapter, okay, but this question or this chapter is your deleted chapter, right? So you need not worry for that, you need not study this chapter, but I will be telling you the answer. For the formation of which compound in Ellingham diagram delta G becomes more and more negative? So that is for carbon monoxide, CO. Okay, so I will not explain anything here because this chapter is not there for your exam. Now coming to question number 9. Which of the following compounds does not give dinitrogen on heating? Again this question is from your P block, right? So this is also deleted portion, oxides of nitrogen, so we will not discuss this question, but I will be telling you the answer. Ammonium nitrate, if you heat, we will not get nitrogen gas. The product here formed is N2O. Okay. Now coming to the 10th question, an aqueous solution of raw sugar when passed over beds of animal charcoal. So this question is from your surface chemistry. Okay. And this chapter is also deleted, so we will not discuss this in much detail. So here you can see adsorbent is where the substance is getting adsorbed. So animal charcoals can behave as adsorbent, so we can eliminate these two options. Adsorbate is the substance which get absorbed, so coloring substance gets absorbed and the process is adsorption. So the correct answer for this question is option number B. Now coming to 11th question, again this is from surface chemistry. Okay, so this question or this chapter is also from the deleted portion, so we will not discuss in detail, but I'll tell you, in Freundlich adsorption, what's the formula used? X by M is equal to Kp1 by N. Okay, now if you take log on both sides, so I'll get log X by M is equal to log K plus 1 by N log P. Right? Now if I write this equation in the form of straight line, I'll get y is equal to mx plus c, right? So what is the slope here? Slope is 1 by n, so that is 1 by n, 1 by n. These two options are incorrect, and the y-intercept is log k, right? That is c, log k. So the correct answer for this question is option number A. But you need not worry, this chapter is deleted, no need to study this concept. Okay, next coming to question number 12, again this is from surface chemistry, okay, deleted portion. Okay, so when FeCl3 is added to excess of hot water, gives us sol X. Okay, deleted, no need to study, no, do not study. Okay, Now when FeCl3 is added to NaOH solution, gives sol Y, X and Y formed in the above process respectively are. So if you add with hot water, it will adsorb Fe3 plus, and if with NaOH it will adsorb OH minus. Okay, so the correct answer for this question is option number C. Now coming to question number 13, which of the following pairs both the elements does not have? So this we have come to D and F block, right? This is one important topic here, so you need to study this chapter. So in which of the following pairs both the element does not have N-1 D10 and NS2 configuration in its elementary state? Okay, so if you know here cadmium and mercury, you need to know their electronic configuration. So what is zinc electronic configuration? 3D10 4s2, right? So then zinc cadmium is 4D10 and 5s2, and mercury is 5D10, mercury is 5D10 and 6s2. Okay, so now which both the element, if you see cadmium and mercury, both are having N-1 D10 and NS2 configuration, so this cannot be the answer. Now here mercury and cadmium only it is given. Okay, so again this two cannot be the answer again. Copper and zinc. So now let us see the configuration of copper. So copper is 3D10 and 4s1. Okay, so copper configuration is this one and zinc configuration is this one. Here both the elements do not have this configuration, right? So the correct answer for this question is option number C. So this question again, if you know the electronic configuration, it is a very easy question. Okay, now let us move towards the next question here, 14. Which of the following is correct with respect to the melting point of a transition element? Again this question has come from your D and F block properties, right? Okay, so now if you have remembered, along the period in the D transition elements, the size first decreases, then remains constant and then increases, right? So now what happens, the melting point depends on the metallic bonding, right? The strength of metallic bonding, and the strength of metallic bonding depends on the number of unpaired electrons, right? So if you see chromium has more number of electrons, so the melting point of chromium is more than manganese. So the correct answer for this question is option number A. Okay, now coming to question number 15. So A MnO4 minus B S2, so this is one equation given, you need to find A and Y respectively. Again this question is from your D and F block, and this question is from some important compounds. Here we studied two compounds, you remember, potassium permanganate and potassium dichromate. So in the reactions of these KMnO4 and K2Cr27, one important reaction is the oxidizing properties. So this is from there, the question is from that topic. So do not ignore these reactions, it is very, very important. Okay, so now how to solve this question? You need to do like little redox reaction chapters you need to study, or you have to know the concepts from there where we need to balance the equation, right? So okay, now let us start here. MnO4 minus and MnO2 will take first, and we'll try to balance this one. MnO4 minus to MnO2. Okay, now if you see the oxidation states here, MnO4 minus is +7 and MnO2 is +4. Now 7 plus 4, the reduction is happening, and reduction is gain of electrons. How many electrons will be gained here? 3 electrons will be gained, right? So plus 3 electrons. Okay, now if you see, next step is to balance the oxygen. Here we have 4 oxygen, here we have 2 oxygen. So to balance oxygen we need to add water molecules. So for 2 oxygen molecule I will add 2 water molecules. Done. Now when I added this water molecule, oxygen is balanced, but at the same time hydrogen is not balanced, right? So here 4 hydrogens have come. So to balance this hydrogen I have to add 4 H plus on this side. Okay, now if you see the equation, OH minus is there, and OH minus happens in the basic medium. So to make it basic medium, I'll add 4 OH minus on both the sides. Okay, so I'll add here another 4 OH minus and 1 4OH minus on this side. Okay, now what will happen? 4H plus and 4OH minus combines to give you 4 water molecule, right? And here we have 2 water molecule. So I'll subtract this 2 water molecule to this side. So finally what equation I'll get? MnO4 minus plus 3 electron plus 2 water, okay, gives you MnO2 plus 2 water. Okay, this 2 water I have already taken to that side, so this is not there, plus 4OH minus. Okay, let us try to understand this step once again. Step 1, what I did, I wrote manganese and manganese product. I found that manganese is +7 to +4, conversion is taking from +7 to +4, that means it is a reduction process, right? Reduction process means there is gain of electrons. So how much difference is there? 3 electrons difference is there, so 3 electrons are gained. Now after balancing this, the second step is to balance the oxygen molecule. Here 4 oxygen, here 2 oxygen, and oxygen is balanced by adding water molecules. So to add 2 oxygen molecules, I added 2 water molecules. Now you see here 4 oxygen and here also it was 4 oxygen. Now when I tried to balance oxygen, hydrogen got unbalanced. So here you see 4 hydrogen have come. So to balance that, I need to add 4H plus. Now this much balancing is done if it is an acidic medium, but here you see OH minus is there, that means it is a basic medium. We need to convert it into basic medium. So to convert that, I will add 4OH minus on both sides. So 4H plus can be neutralized by 4OH minus. So when you are adding this 4OH, you have to add 4OH on this side also. Now if you see 4H plus and 4OH minus gives you 4 water, and this side we have 2 water, so that will become this side and we will be subtracting it, and this becomes 2 water on left hand side. So the final equation now I have is MnO4 minus plus 3 electrons plus 2 water gives MnO2 plus 4OH minus. Now let us check whether this reaction is balanced or not. Okay, so we have 1 Mn and we have 1 Mn. Mn is balanced. Oxygen, you have 2 oxygen and 4 oxygen here, so total we have 6 oxygen, and here we have 4 oxygen and we have 2 oxygen, so 6 oxygen. Oxygen is also balanced, right? Now if you see hydrogen, we have 4 hydrogen and we have 4 hydrogen here. Hydrogen is also balanced. Now also we need to check the charge, whether charge is balanced or not. So here if you see there is 1 negative charge, 1 negative, 3 negative charges there. So the total charge on this side is -4. Now if you see on this side it is 4OH minus, that is also -4. So charge is also balanced. Okay. So now if I write the final equation, what I got for Mn is, okay, I'll erase all other reactions here, so to avoid all type of confusions. So this is the final equation that I have got, that is MnO4 minus, okay, I'll erase everything. We have, so let us write it properly once again. We have MnO4 minus plus 3 electrons plus 2 water gives MnO2 plus 4OH minus. Okay, this, remember, this reaction we have done. Now let us try to balance this S2O3, this part reaction. Okay, so let us do this. Here I am taking it another slide so that we can do it clearly. S2O3 2 minus is getting converted to SO4 2 minus. Okay, now if you see here, first of all we need to balance the we need to check the oxidation state, right? So if sulfur is X, so we have 2X here, and oxygen is -6, and I'll get -2, so I'll get X is equal to +2, right? So here the oxidation state of sulfur is +2 and here it is +6. Got it? Okay, so now if you see, next part is to balance the number of sulfur atoms. You see on the left hand side, next part is to balance the atoms, right? So on the left hand side we have 2 sulfur, on the right hand side we have 1 sulfur. So I'll take a multiply 2 here. Okay, now let us see oxygen. Here you see there is 3 oxygen and here we have 8 oxygens. I told you to balance oxygen we need to add water molecules. So this side there is 3, this side this is 8. So we need to add another 5 oxygen on this side. So for that what I'll do, I'll add 5 water molecules. Okay, okay, one more thing we need to see, the charge, right? So charge here it is +2 to +6, right? +2 to +6 oxidation has taken place. That means loss of electrons has taken place by how many? By 4 electrons. But here one important thing to note is, for one sulfur the oxidation state is changing from +4 to +6 from one sulfur. We have 2 sulfurs, so total electrons lost will be 8. Are you getting? For one sulfur to convert from +2 to +6, it has to lose 4 electrons. But we have 2 sulfur on both the sides. So for one sulfur, if it is 4 electrons, for 2 sulfur it will be 8 electrons. So this side there will be loss of 8 electrons. Okay. Now if you see, when we balance this oxygen, the hydrogen got imbalanced, right? Now here we have 10 H plus, but here we do not have any H. So I will add another 10 H plus on this side. Okay, so now this side it will become 10 H plus. Now you see, this reaction is in basic medium, so balancing we have to add OH minus on both sides. So again I'll add 10 OH minus on this side, and I'll add 10 OH minus on this side. Now you see, this 10 H plus and 10 OH minus can give me 10 water molecules, right? And 10 water molecules, and this side we have 5 water molecules. I'll take that to this 5 water molecules to this side, and finally I'll get the equation as okay, let me write the final equation now. We have S2O3 2 minus plus 10 OH minus, okay, then it is giving me 2 SO4 2 minus plus 8 electrons, and then 10 water minus 5 water, we have 5 water. Okay, now let us check whether this reaction is balanced or not. We have 2 sulfur here, we have 2 sulfur here. Yes, it is balanced. Oxygen, if you see, we have 3 oxygen here and 10, so total 13 oxygen we have here, and here if you see 4 2s are 8 plus 5, 13 oxygen, that is also balanced. Hydrogen, 10 hydrogens here, and we have 10 hydrogens here. Now talking about the charge, if we see about the charge here, it is -2 and this is 10 negative. So total 10 negative and 2 negative, we have the charge of -12 on this side. Now if you see the charge on this side, that is 2 2s are -4 and then 8 minus, so total again -12. So that is also balanced. So this equation is also balanced, and the previous equation that we wrote was also balanced. Now let us write that equation here and see. Okay, so what is this equation? MnO4 minus plus 3 electrons plus 2 water. So let me write down that on this side. So I have MnO4 minus plus 3 electrons plus 2 water. That is giving me MnO2 plus 4 OH minus. Okay. Now if you see, the number of electrons should be lost or gained should be same, right? Here 8 electrons are gained, and here 8 electrons are lost and 3 electrons are gained. That is not correct. So we need to make the number of electrons also same. So for that, what I'll do, I'll multiply this equation with 3 and I'll multiply this equation with 8. Okay, now we will multiply this and rewrite the equation. So what I'll get, 3S2O3 2 minus plus 30 OH minus will give me 3 2s are 6 SO4 2 minus plus 24 electrons plus 15 water. Okay. Now if I multiply 8 in this equation, then I'll get 8 MnO4 minus plus 24 electrons plus 16 water. That will give me 8 MnO2 plus 32 OH minus. Right? Now what we can do? We can check and multiply and cancel the things. Now let us see first. 24 electrons and 24 electrons will get cancelled. So final equation I'll be writing here. So I have 8 MnO4 minus, okay, plus 3 S2O3 minus. Okay, I have written this one, I have written this one. Then I have 30 OH here and 32 OH here. So this will go on that side. Okay, and I have 16 water here and I have 15 water here. So this water will come here and I'll get one more water molecule here. Okay, and then if you see 6 SO4 2 minus plus 8 MnO2 Okay, now 32 minus 30, it is 2OH minus. Okay, so now this is the final equation that we have got. You have seen a lot of little, yes, this is a little lengthy question, but yes, not difficult one, but yes, lengthy question. Okay, so now let us check once again whether the reaction is balanced or not. 8 manganese balanced, 6 sulfur balanced, 4 is a 32, 32 plus 9, that is 41, and then we have 41 plus 1, 42 oxygens are there. Here if you see 6 4s are 24, then we have 24 plus 16, 40, and then 2, again 42 oxygen. Hydrogen, if you see, we have 2 hydrogens here and we have 2 hydrogens here. So manganese, sulfur, oxygen and hydrogen are balanced. Now let us talk about the charge. Here you see it is minus 8 and minus 6. So total charge is minus 14. Now if you see here, 6 2s are minus 12 and minus 2 again minus 14. So total minus 14, that is also balanced. So now we can answer this question. The question was to find out A and Y. Okay, so A is the coefficient of MnO4 and Y is the coefficient of SO4. So A is this one. A is the coefficient of MnO4, so A is equal to 8 and Y is for SO4 and that is 6. Okay, so answer has to be 8 and 6. So the correct answer for this question will be option number A. Okay, now let us move towards the next question. So again this question is from coordination compounds. Okay, so another very high weightage topic, coordination compounds. And here we have, this is from nomenclature. The subtopic here is nomenclature. Okay, now which formula and name combination is incorrect? Okay, you have to tell about the incorrect combination. Okay, so now if you see, the name should be, first we need to name the ligands, then we need to name the metal, and then we need to write the oxidation state, right? So and the ligands name should be alphabetically ordered. So here it has to be first amine. So diamine, this part, it is correct. Then it is chlorido, that is also correct. Nitrito N, then platinum, and if you calculate the oxidation state comes to, so yes, this naming is correct. Now if you see the next one, again dichloridor, this is correct. Here diethylidene diamine, anything wrong can you figure out here? We have seen that for bidentate, tridentate ligands, if there is more than one such ligands, we use the word bis, tris or tetratis, right? We do not use di, tri for these type of ligands. I hope you remember this rule. If yes, then we can definitely tell that this di is the incorrect thing present in this nomenclature. So that is why the incorrect answer will be option number B. Means the incorrect naming is option number B, and that is our answer because the question has asked you for incorrect answer. Okay, so I hope you have done this, you would have done this. So again this question I will level it as easy question. Okay, previously we did not give a remark, so I think this one is a little difficult question because it is lengthy and you need to do a lot of calculations here. Then okay, here this one also I will mark it as easy question because this is directly from your properties and trends. Okay, so now coming to 17th question, which of the following system in an octahedral complex has the maximum number of unpaired electrons? Again this question is from coordination chemistry, right? And can you tell me the subtopic here? Yes, the subtopic here is D, crystal field splitting. Okay, now D6 low spin. Low spin means what? That pairing will take place, right? So we have like this, the orbitals are in like this, these are 3 orbitals here and this is 1 orbital here, this is T2G and this is EG. Now when it is low spin, pairing will take place here. If it is high spin, then it will go to the upper level, right? So now if D6 low spin is there, so remember low spin means pairing and high spin means no pairing. Okay, so now let us try to fill this using these options, using this diagram. Now D6 low spin means first 6 1 2 3. Now 4th, 5th and 6th will not go to the upper level because it is low spin, so pairing will take place. I'll get 4th, 5th and 6th. right? So what is the electronic configuration here? T2G6, and number of unpaired electrons is 0, right? You see any unpaired electron here? No. Okay, now let us move to the next option like this. So let me erase this one. Okay, so next option, if you see D4 low spin, again D4. So we have 1, 2, 3, and the fourth electron will come here. Again pairing will take place because it is a low spin. So here what is the configuration? Configuration is T2G4, and number of unpaired electrons is 2. You can see 2 unpaired electrons are there. Now coming to D7 high spin. So how we can fill this one? D7 high spin. So if you see 1, 2, 3, 4, 5. So why I took 4 and 5th electron to the upper level now? I hope you have understood, because here it is high spin. No pairing will take place. So 1, 2, 3, 4, 5, and then 6 and 7. So we have 3 unpaired electrons. So D7 we have the configuration as T2G3, T2G5 and Eg2, and the number of unpaired electrons are 3. Now coming to D9 high spin. Okay, so if you see D9 high spin, okay, let us fill it like this now. D9. So we have 1, 2, 3, 4, 5, right? Because it is high spin, so no pairing will take place. 1, 2, 3, 4, 5. Then I have 6, 7, 8, and then 9. So I have 1 unpaired electron here, right? So you can see which is having the maximum number of unpaired electrons. That is option number C, D7 high spin. Okay, so this question is again easy if you have understood the concept of crystal field splitting. Okay, now let us move towards the 18th question, the correct decreasing order of basicity of hydrides of group 15 elements. So we have moved to P block and group 15. So you know basicity will decrease down the group. So nitrogen, phosphorus, arsenic, antimony. Okay, so yes, this topic is also from your deleted portion. Okay, so you did not study this one, but this will be the answer. Okay, now coming to the 19th question, which one of the following oxo acids of phosphorus can reduce AgNO3 to metallic silver? Again this is from your P block, group 15, but need not worry because it is deleted portion. So here the answer is your H3PO2. Okay, H3PO2, because it has one. If you see the structure of this one, it is PO, then we have OH, and we have, okay, yeah, so H3PO4, there is one this hydrogen which can reduce the AgNO3. Okay, so the correct answer for this question will be option number D. Let us move to question number 20 here. In solid state, PCl5 is in the form of, so again this question is from your P block. Okay, P block group 15. Okay, so in the solid state it exists as PCl4 and PCl6. So the correct answer is option number 5, option number B. But again remember, this is from your deleted portion. Okay, you need not study this chapter. Now coming to 21. Okay, so now we have moved to organic chemistry. Identify A, B and C in the sequence. So CH3, CH2, Br, you have treating it with KCN. So if you remember, we'll get CH3, CH2, Cn, right? So your option A should be CH3, CH2, Cn. So you can eliminate this option where it is NC, right? These three options can be there. Now LiAlH4, if you treat, it will reduce this one. I'll get CH3, CH2, then CH2, then NH2. We'll get a amine here, right? So here you see in B we are getting an alcohol. This cannot be the answer. So yes, this can be answer, but here one carbon is less, right? So this can also not be the answer. So the correct option is answer number D. But we'll see the next reaction. When you treat it with HNO2, what will happen? This one will get converted to OH. So I'll get CH3, CH2, CH2, OH, right? So the correct answer for this question is option number D. Okay, now coming to question number 22 here, again a reaction based question. So I'll mark this question as easy. Very easy reagents have been given. I think this is easy for everyone. Okay, now let us go to the next question. We have CH3, CH, double bond CH. So PCC is there. So what is the work of PCC? It converts primary alcohols to aldehydes, right? So they have already given you. Now hybridization changes involved in carbon 1. So what is the hybridization? So if you see here, this carbon, it has 2 hydrogens here, CH2 OH, and this side one carbon is there, then this side this part is attached. Now you see there is 4 sigma bonds. If there is 4 sigma bonds, the hybridization will be sp3, right? So from it was sp3, so we can eliminate these two options. Now if you see this one, this is my carbon 1, okay, this is also carbon 1 because it contains the functional group. So I'll have COH here, this structure, and this side C, and this side rest part is there. So now if you see here, we have 3 sigma bonds. 3 sigma bonds means the hybridization is sp2, right? So the hybridization changes from sp3 to sp2. So the correct answer for this question is option number A. Now coming to the next question, 23. In a didentate ligand, if a didentate ligand ethane, okay, so 1, 2, so this question is again from your coordination chemistry. Coordination chemistry, and it is from color concept. Okay, if a didentate ligand ethane 1,2-diamine is progressively added in the molar ratio of 1:1, 2:1, 3:1, and the following coordination entities are formed. So they have given you the products, they have given you the colors. The wavelength in nanometer of light absorbed in case of 1 and 3 are. Okay. So here you need to know the concept of complementary colors. So I'll draw here. See, V, B, G, then you have Y, you have O and R. So now you see, if a color is visible as blue, okay, if the color is visible as blue, it will absorb orange, the opposite color. So what I'm saying here is, if a substance is visible as blue color, then it must have absorbed orange color. If a substance is visible as green color, it will absorb red color. If a substance is visible as yellow color, it will absorb violet color. Okay, this is called complementary color theory. Now let us see the first one. First one is the substance is visible as pale blue, right? So if the substance is visible as pale blue, then it will absorb somewhere around orange, something orange yellow range, right? So now if you see, this one is 700 nanometer and this one is 400 nanometer. Red is 700, violet is 400. So this one should be in between somewhere 600 something, right? So you see 300, option A. First 300 and 310 are very far away, they are not even nearer to 600. Now if you consider this one, 475 and 600 can be somewhere answer, we can guess. Now coming to the third one. The third one is violet, right? It is visible as violet, okay? Then it will absorb around yellow color, right? It will absorb yellow color. Again the range is somewhere 700, this is around 600, this may be somewhere around 500, right? Not the exact range, but somewhere to near that. So this must have absorbed yellow color. So yellow color means the range should be around 500. So here you think this can be 500, but this option here, it is 300 again, which is very less. So the correct answer for this question has to be option number C. Okay, I hope this is clear. Once again let me repeat, color theory you need to know opposite colors are accepted. So violet, brown, blue, green, yellow, orange, red. So if a substance is visible as pale blue color, it will absorb orange color. Orange, yellow, pale blue means or somewhere between orange and yellow. So the range should be between 500, 600, right? So 300, 310 is very far, we can eliminate those options. We are having 600 and 475. Next coming to violet, because it is asking for the third compound. Violet means it should add, it should be absorbing somewhere around yellow color, and yellow color it will be somewhere in this range. Okay, so correct answer for this question is option number C. Now coming to question number 24, which of the following is an organometallic compound? Again this is from coordination compound. So organometallic compounds means you need to have a metal in some organic compound. So CH3, CH2, Mg, Mr, the Grignard reagent is an example of organic compound, because here we have in an organic compound we have a metal. Okay, so correct answer is option number A. Now here what is there? Next if you see, this is an ion, this is also a salt, these all are your salt. Okay, these are not molecular compounds, so we can eliminate option B, C and D. Now coming to question number 25, a pair of compounds having the same boiling points are. So okay, N-hexane and neohexane. Here there is branching, so boiling point will be less. Here the boiling point will be more. Benzene and naphthalene. So naphthalene will have like a bigger compound, it will have higher boiling point. But if you see butane 2-OL and butane 2-OL plus and minus, dextrorotatory and levorotatory compounds. So these are your stereochemical properties. They do not affect the physical properties. So the boiling point of plus butanol and minus butanol will be same. So the correct answer for this question is option number C. Okay. Now coming to question number 26. In the reaction, okay, you have been given a reaction, you need to find the products and you have to tell the name of the reaction. Okay. Now C6H5Cn SnCl2 HCl H3O plus, if you remember, this is your C6H5, we have Cn, right? If you add these reactions, this is your Stephan reduction and it will get converted to C6H5CHO. Okay. Now concentrated KOH is your Cannizzaro reaction where the same compound undergoes oxidation and reduction, right? So if this compound, that is benzaldehyde, undergoes, so I'll write like this, benzaldehyde undergoes oxidation, okay, so this group will be converted to acid, so we'll get COO minus K plus, okay. And if this is converted, if it is undergoing reduction, okay, then we will find if it is undergoing reduction, it will convert to alcohol, so I'll get this compound. Okay, so this is your first one is Stephan reduction, so we can eliminate all the options here, and the next one is Cannizzaro reaction. So the correct answer for this question is option number C. Okay. Now let us move to the next question, that is question number 27. Compounds P and R in the following reaction are. Okay, so let us try to figure out the products for this reaction. CH3CHO with a Grignard reagent. You know Grignard reagent, the nucleophilic addition reaction takes place. So how will you do? We know CH3COH is there. Okay, and we have CH3MgBr plus CH3MgBr. The best way to solve these type of questions is to identify the plus and minus. Okay, so what is the plus and minus? I'm saying, see, oxygen is negatively charged, carbon is positively charged. Here magnesium is positively charged because it is a metal, this is negatively charged. What we have to do, negative will attach to positive, positive will attach to negative. So what product I'll get here? CH3C, we have H, okay, here we have O. O minus will get OMgBr because this is the plus part, and this plus will get you CH3. Okay. Now when you treat it with H3O plus, this OMgBr will get converted to OH. Okay. So this is the thing I got. Okay, next it is concentrated H2SO4 and heat. So if you do concentrated H2SO4 and you heat it, then it is dehydration reaction. So what will happen from here? So I can write it like this. Let me represent it, H2 and H. Okay. Okay, so now what happens, this OH and H can be removed from dehydration. So what I'll get here, CH3 CH double bond CH2. Okay, now coming to B2H6 and H2O2OH, man, what does this do? Add H plus and OH minus according to anti-Markovnikov's rule. Anti-Markovnikov's rule, right? So if I add this one here, what I'll get? CH3 CH CH2 OH here and H here. Okay, so now the question is asking the relation between P and R. So let us name the products here. So P was the first product, this is my P. Okay, second one, this is Q, and then this is R. So in P, OH is present in the second carbon, in R, OH is present in the first carbon, right? So these are what? Positional isomers. Okay, so the correct answer for this question will be option number D, that is position isomers. Now let us see the next question, 28 here. Aniline does not undergo. So this is one of the very important reasoning questions which is even asked in your board exam. Aniline does not undergo Friedel-Crafts reaction. Why? Because it reacts, aniline structure if you know, this is NH2, right? And we in Friedel-Crafts reaction we take CH3Cl and AlCl3. Now this is a Lewis acid and this is a Lewis base. So this acid base reaction takes place and the electrophile cannot be generated, right? So that is why aniline do not undergo Friedel-Crafts reaction. So the correct answer for this question is option number B. Now coming to the next question, 29. The heating of phenyl methyl ether with HI so produces an aromatic compound A, which on treatment with concentrated HNO3 gives B. So A and B respectively are. So this question is from your ethers chapter, right? Alcohol, phenols and ethers. So phenyl methyl ether. So the compound here is phenyl methyl ether. Now if you treat it with HI, we'll get phenol OH, okay, and then we'll get iodomethane CH3I. Now what is happening? This one, the which on treatment with concentrated HNO3. So this one, if it is treated with concentrated HNO3, then I'll get OH and NO2 and 3NO2. All the positions are substituted in this case, right? So the correct answer here, this compound is called as picric acid. So if you see the first compound that I got, this is A, and when A is treated with concentrated HNO3, I'll get B, that is picric acid. So the correct answer for this question is option number C, okay, phenol and picric acid. Now coming to question number 30 here. Okay, again this is from the reaction based question. OH with NaOH. So what will be the product here? A. OH with NaOH, I'll get ONA. This is A. Okay. Now OH ONA with CO2. So what will happen? This one will do carboxylation. So I'll get here. Then again H plus treat is there. So I'll get COOH. Next C. When you treat it with CH3CO whole 2, so that acylation takes place and we will get OCOCH3, okay, and COOH, okay. So this compound name is aspirin. So the correct answer for this question is option number A. So yes students, this was the part 1 of KCET 2023 chemistry paper solution, where we have discussed the first 30 questions. So I want all of you to do these questions, practice by your own and write down your scores in the comment section, okay. So please watch in the next part the rest of the questions, that is question number 31 to question number 60. So please stay tuned and all the very best for your KCET 2025 examination. Work hard and prepare hard. Thank you, and please subscribe the channel for more updates.